students, and welcome to today's lesson. I'm Mrs. Levine. Today, we will explore the question, what causes a moving object to slow down and stop? Are you ready? Grab your pencil and your science journal and let's get started. I have a video clip to show you. As you watch, focus on the motion of this golf ball. Ready? What changes in motion do you notice? I noticed that the golf ball starts at rest. And then the golf ball moves in a straight line. What forces acting on the golf ball cause its motion to change? Well, the golf club exerts a force on the ball, right? The force from the club causes the ball to change speed and direction. In other words, the ball moves forward. The ball moves because the force exerted by the golf club is stronger than the force exerted on the opposite side. Now we'll watch a little more of the video clip. What changes in motion do you notice this time? I noticed that the ball slows down and then it stops. Once the golf ball stops, it stays at rest and doesn't move anymore. But why do you think the ball slows down and stops? Is another force acting on the golf ball as it slows down and stops? Yes, I think another force must be acting on the golf ball after it is hit, because slowing down and stopping are changes in motion. Now I have a new question. What causes a moving object to slow down and stop? Could the surface that the golf ball is moving across have something to do with the golf ball's change in motion? Let's investigate and see what we can find out. Before we start our investigation, I want to show you another video clip. The people in this video clip are playing golf. The surface of a golf course is usually made of different materials designed to challenge players. As you watch, pay special attention to the materials the golf ball travels across after the golfer hits the ball. What do you notice about the materials the golf ball travels across after the golfer hits it? Do you notice that the golf ball rolls quickly across short grass at first, and then it slows down and stops in the tall grass? Whoa! I wonder, how do the different types of grass affect the golf ball's motion? The video clip seems to show that the material a ball rolls on affects the motion of the ball. How can we investigate this idea further? Where shall we start? Well, we'll need to see what materials we have available, and then we'll make a plan using those materials. Here are the materials we have available to use. We have a ball as well as pieces of artificial grass, foam rubber padding, and burlap. We also have a grooved ruler, a meter stick, and a wooden block that we can use in our investigation today. But in order to plan our investigation, we need to know what questions we are trying to answer. We should be able to use our questions and the materials to investigate the force that causes a moving ball to slow down and stop. What questions do you have? Maybe you wonder, what material will the ball roll the farthest on? Or how does the type of material change the distance the ball travels? Those are great questions. Now that we have some questions ready, let's think about how we can use our questions to design an investigation. Based on our questions, what variable should we change to help us understand the force that causes a ball to slow down and stop? We noticed that the golf ball rolled faster on shorter grass than on longer grass, which made us wonder if the surface the ball rolls over affects its motion. So I think we can change the type of material the ball rolls on. Then we can observe how the ball slows down and stops on each one. Let's create a fair test guidelines chart where we can record information about the investigation. In a fair test, we change only one condition at a time and keep all other conditions the same. Remember, any condition that can change is also called a variable. So we will change one variable at a time in this investigation and keep all other variables the same. The one variable we will change is the material the ball rolls on: burlap, rubber padding, and artificial grass. Great, let's add that information to our chart. We'll also need to make sure we have a testable investigation question before we get started. Remember, a testable question is one that can be answered by using evidence gathered through investigation. What question could we ask? Well, let's revisit these questions. What material will the ball roll the farthest on? And how does the type of material change the distance the ball travels? What bigger question can we answer as we gather data about these questions? How about how do different materials affect the distance the ball travels? Let's add that question to our fear test guidelines chart. But to test this question, we need the ball to travel, right? How can we get the ball to travel a distance? Look at our materials again. What ideas do you have? Oh, look, we have a ruler and a block. We can create a ramp by leaning the ruler against the block. Then we can release the ball so that it travels down the ramp and onto one of our three materials: burlap, rubber padding, or artificial grass. Our investigation setup is looking good, but have we designed a fear test yet? What else do we need to consider? Oh, I know, we can only change one variable, right? So what other variables should we keep the same? Well, we need to think about the placement of the material. We'll lay the material flat on a smooth, hard surface. We also need to consider the placement of the ball. We'll place the ball in the same starting position each time at the top of the ruler. Finally, let's think about the speed of the ball. We should roll the ball the same way each time so that the ball's starting speed is the same. Let's add all of this information to our fear test guidelines chart. For a fair test, we also need to make sure that we gather data in the same way each time. How can we make sure we gather data consistently and accurately? We'll take measurements and record data in a table. But what are we going to measure? Maybe we need to measure how far the ball rolls. We need another ruler. Let's look at our investigation setup from a bird's eye view, which means we'll look at our investigation setup from above. We can use a meter stick to measure in centimeters the distance the ball travels before it comes to rest. We'll place our meter stick at the end of the ramp. We have to make sure the zero on the meter stick is lined up with the end of the ramp, so we can gather our data as accurately as possible. I wonder how many centimeters the ball will travel on each material. On which material will the ball roll the farthest distance or the shortest distance? Let's make some predictions about how the different materials will affect the distance the ball travels. On which material do you think the ball will roll the farthest distance? Point to the material. Why do you think that? On which material do you think the ball will roll the shortest distance? Point to the material. Why do you think that? Great, we have our fear test investigation planned out, and we've even made some predictions. Now let's investigate to see if our predictions are supported by the data we collect. Let's watch this video clip to see how far the ball rolls on burlap. Wow, for trial 1, the ball rolls 45 centimeters. We have our first data point. Since we are conducting a fear test investigation, I will repeat the steps for 3 more trials. For trial 2, the ball rolls 44 centimeters. For trial 3, the ball rolls 45 centimeters. For trial 4, the ball rolls 43 centimeters. I'm curious to see how far the ball will roll on the other materials. Let's see how far the ball rolls on the rubber padding. Wow, for trial 1, the ball rolls 59 centimeters. Just like we did for the burlap material, I will conduct 3 more trials. For trial 2, the ball rolls 59 centimeters. For trial 3, the ball rolls 60 centimeters. For trial 4, the ball rolls 59 centimeters. Let's keep going. I wonder what distance the ball will travel on artificial grass. Let's see. Oh my, for trial 1, the ball only rolls 14 centimeters. Again, I will conduct 3 more trials. For trial 2, the ball rolls 15 centimeters. For trial 3, the ball rolls 15 centimeters. For trial 4, the ball rolls 15 centimeters. We've collected some useful data. Now's a good time to revisit your predictions from earlier. Look at the data in the table. Can you use the data to support your predictions? Your task for today will be to answer this question in your science journal. Use the measurements we recorded for the different materials to help you decide. Watching the ball roll on different surfaces reminds me of the golfer we watched at the beginning of the lesson. Golf would sure look different if people played it on burlap or rubber. We will analyze and interpret our data in our next lesson. Then we can decide how the different surfaces affect the motion of our ball and most likely a golf ball too. Let's review your task for today. Answer the question about using the data to support your predictions.